Okay, so measuring the density of air, we need to do this for the exam. There is past year questions asking for a proper procedure in this. You don't really need a diagram, because it's quite difficult to draw a diagram for this, but you do need a step-by-step process. Okay? Now we're going to talk about a rigid container. The container we had wasn't rigid, but it's much easier to talk about a rigid container, because then you're assuming that there was no, you can pump all the air out, and then the mass is the total air that was in the container. Right. So what we do is you'd measure the mass of a container. Then you would pump extra air into it to force, kind of pressurise the air. You would then measure the new mass of the container, and then when you release the valve, the air is allowed to come out. Okay? And then you measure the volume of air that is. So step one is measure the mass of a rigid container. There's no point measuring the mass of a balloon. It ain't going to work properly. Mass of a rigid container. Okay, then we're going to pump, you're going to pressurise it by pump more air into it. So pump more air into the container. What is that noise?
Really annoying.
Pump more air into the container and close the valve. So you've got a pressure. So this is pressurised. Pressure at, oh god. It's pressurised. I think that's how you spell pressurised. Pump more air in the container and close the valve. So it's now a pressurised container. Then would measure the new mass. And then finally, you would release the air. Release the air into a measuring cylinder underwater. Release the extra air into a measuring cylinder.
Submerged.
Submerged underwater. Now, you might have to draw a diagram for that bit. So you might need a diagram for this, just to help explain what you mean by that. But you don't, if you can explain it well enough without a diagram, you don't need to. Right, so the final part, part 5, last part, which is just using the formula to work it out. I'll just do this as a formula. So part 5, 5 steps. So the density of the water, so density of the air, sorry. Density will equal, so density for this one is going to equal to the mass of the full container minus the mass of the empty container divided by the volume of the air. So it's mass of, just put extra air, minus the mass of original container, all divided by volume released. Okay, so that should be how you would measure your density of air. Any questions about that?
Volume release.
The volume of air released. Volume of air released. You can put volume of air released, something like that, doesn't matter. As long as you know what I mean, volume released, the volume of air released from that. Any questions?
How do you get the water?
You have to fill the submerged cylinder up with water and then tip it into the container with the water in it, and the water stays in it.
Actually, I was wondering, just like 2 minutes ago.
You put the mass of extra air minus the mass of the original. Is it, you don't need the mass of the original because it's mass of the original minus the.
You know what it means?
And that means the mass of the extra air. I know what you mean, I got confused too. I got
Sorry?
confused also.
Tell me so I don't
No,
get
it's
confused.
like massive extra air. I thought it should have been massive extra air all over volume of police.
That is right,
Oh,
but
that's
it's
what I'm
mass
thinking.
of extra air container minus the mass of the original container to get the overall mass difference. Okay? So it's just the mass difference you want divided by the volume of air released. Okay? Which is essentially rho equals m over v. And you get your answer in kilograms, meters to 93. Okay? Make sure that you keep your volume as meters cubed or millilitres, and make sure you keep these two as kilograms.
Milliliters is centimeters cubed.
Okay, so meters cubed is what?
A litre.
Liter.
So why did that not work
No,
out
it's
at
not a
all?
litre, it's millilitres divided by 100.
Is it?
Yeah, because a centimetre's 10th of a litre.
So a milliliter is a centimetre cubed.
Yeah.
Yeah.
So when we did that on the experiment,
I did it.
no, because you get the right answer.
Exactly, man. Jesus.
So it's not meters cubed then. Centimeters.
No, that's the units for density.
Just
We get 506.
This should be kept as meters cubed, whatever that is.
What is that?
well then if it was meters cubed then it would have been what the first one was, would it not?
No.
Meters
What's
cubed's
that?
10 litres.
Let's go back to this one, like.
Millilitres into litres divide by 1,000. Millilitres into meters cubed would be divided by.
Right, so if that's
Either 10 or
millilitres,
100.
right? That's millilitres, that's centimetres cubed.
Uh-huh.
So what's that? Is meters cubed?
Divided by 1,000.
No, divided by.
No, it's not 1,000 because it's
It's 100.
Yeah.
0.1 by 0.01 by 0.01.
I've lost this conversation.
It's divided by 100.
Over my head.
So it'd be 5.78.
5.78. So do 0.094 divided by 5.78. What do you get? 0.0094 divided by
We just give
5.78.
626 times 10 to the negative 3.
1.66 times 10 to the negative 3. You must put in an extra zero or something.
I love it, man.
Right, let's go back to that now. Let's go for a break and I'll think about it.